Hi everyone. In this video, you're going to learn how to solve even more trig equations. In our last video, you learned how to solve basic trig equations, and so now we're just going to look at some additional scenarios that you might run into when you're solving trig equations. Okay, so that first scenario that we want to look at is solving equations with the reciprocal functions. So remember, the reciprocal functions are secant, cosecant, and cotangent. So what you want to do when you're solving equations with the reciprocal functions is you start out the same way you would even if the trig function was sine, cosine, or tangent, meaning you want to get the trig function by itself. Okay, so in our first example, we have secant of theta minus 2 equals 0. So I would actually start by adding 2 to both sides, isolating secant of theta. Okay, so after you get the trig function by itself, then what we want to do is change the trig function to its reciprocal. So for example, secant is the reciprocal of cosine. So we know if secant of theta equals 2, then cosine of theta would equal 1/2. 1/2 is the reciprocal of 2. Okay, once you make that change, then you just proceed like you already know how. In order to isolate theta, we have to use the inverse trig function. So our next step would be to write inverse cosine of 1/2 equals theta. And then we're going to think to our unit circle for which angle is cosine equal to 1/2. Well, cosine is equal to 1/2 at pi over 3. And then remember, because we're solving for cosine, we can just put a plus minus in front of the pi over 3. That'll account for the two angles where cosine is 1/2. And then, because that terminal side is going to continue to rotate around the unit circle, we want to add 2n pi to find all the solutions. Okay, let's look at our next example. We have cosecant of theta minus the square root of 2 equals 0. So the first thing we want to do is isolate the trig function. So I'm going to add square root of 2 on both sides. And we get cosecant of theta equals square root of 2. All right, then we're going to change it to the reciprocal function. Cosecant is the reciprocal of sine. So if cosecant theta equals square root of 2, that means sine of theta would equal the reciprocal of square root of 2. Now, to find the reciprocal, you'd want to make it a fraction by putting a 1 under it and then flip it. Now, at first, you may not recognize 1 divided by square root of 2 from your unit circle. But if you rationalize the denominator, we then get sine of theta equals square root of 2 over 2. And that you probably recognize on the unit circle. Okay, now to solve for theta, we're going to use our inverse trig function. So inverse sine of square root of 2 over 2 will equal theta. All right, then we just have to think to our unit circle for which angle is sine equal to square root of 2 over 2. Well, hopefully the first angle that comes to mind is pi over 4. And of course, we'll still add the 2n pi. But there is another angle where sine is equal to square root of 2 over 2. And an easy way to find it is to just calculate pi minus pi over 4. And then, because we need a common denominator, we'll make pi 4 pi over 4. And then 4 pi minus 1 pi gives us 3 pi over 4. And then we'll also add the plus 2n pi. Okay, so these are all the solutions for theta. All right, so that's how we deal with reciprocal functions. All right, the next thing I want to show you is that you can often solve trig equations by factoring. So anytime we're trying to solve an equation by factoring, we always want to set the equation equal to 0 first. So that's exactly what you would do to start both of these equations. But let's look at the first example. We have sine of theta times cosine of theta equals cosine of theta. So I'm just going to subtract this cosine of theta and move it to the left side. So I'll have sine of theta times cosine of theta minus cosine of theta equals 0. Okay, so now we want to do our factoring. Now, this is one example where we can factor out the greatest common factor. Okay, now what is common to both terms? Well, remember, the terms are what you subtract. So these would be the terms of the equation. And notice that cosine of theta is common to both terms. So that is our greatest common factor. So we're just going to factor out cosine of theta. Now remember, when you factor out cosine of theta, to figure out what's left, you basically divide each term by cosine of theta. So if I do that, I'll be left with sine of theta minus 1 equals 0. Now that's helpful because now we can just set each factor equal to 0, and then we just solve each of those basic trig equations separately. Okay, so we'll have cosine of theta equals 0 and sine of theta minus 1 equals 0. All right, to solve cosine of theta equals 0, because the trig function is already isolated, we can go right to our inverse trig function. So inverse cosine of 0 equals theta. And we just have to think to our unit circle, for which angle is cosine equal to 0? Well, hopefully you're thinking pi over 2 at the very top of the unit circle. And of course, we can just put a plus minus in front of the pi over 2. And then add 2 and pi. All right, now to solve sine theta minus 1 equals 0, we want to start by adding 1 on each side. And we get sine of theta equals 1. Okay, then we're going to use our inverse trig function. Inverse sine of 1 equals theta. And then we just have to think about our unit circle, or which angle is sine equal to 1. Well, actually, hopefully you're thinking pi over 2 again at the very top. And you guys, technically, whenever we're solving for sine, to find the second angle, we would do pi minus pi over 2. But pi minus pi over 2 is pi over 2. So you're just going to end up with the same angle. Or another way you can think of it is, you know, sine is only equal to 1 at the top of the unit circle. So, okay, and now we have all of our solutions. All right, now for our second example, again, we're going to start by setting the equation equal to 0. So to do that, I'm going to break down the sine squared theta. I'm going to subtract the 2 sine theta, and I'm also going to subtract 3. Okay, and that'll set my equation equal to 0. All right, now, this equation, we are going to factor, but we're actually going to factor it like a quadratic. Because see how we have the sine squared, and then we have sine? Like this is very similar to x squared minus 2x minus 3 equals 0. If I just replace sine theta with x. And so remember, to factor the quadratic, we would just think factors of negative 3 that add to negative 2. So that would be negative 3 positive 1. Well, the trig equation is going to factor the same way, but instead of x, we're just going to use sine of theta. Okay, and once we have it factored, then we'll just set each factor equal to 0, and then solve each equation separately. Okay, for sine theta minus 3 equals 0, I would start by adding 3. Okay, then you might use your inverse trig function. But hopefully at some point you recognize that there actually is no solution to this equation because sine is never equal to 3. Remember, the range for sine is -1 to 1. You know, and that becomes the domain of your inverse trig function. So there actually is no solution to this equation. But that's okay, we have one more to solve. So here I would start by subtracting 1 on each side. That gives me sine of theta equals -1. Then we will use our inverse trig function to isolate theta. And then we'll just have to think through a unit circle for which angle is sine equal to -1. Well, that would actually be, now if you're thinking 0 to pi over 2, or excuse me, 0 to 2 pi, which is 1 revolution on your unit circle, then you're probably thinking 3 pi over 2, which is fine. You can put 3 pi over 2. But I'm going to use, since we're evaluating that inverse trig function, instead of 3 pi over 2, I'm going to use -pi over 2. And that's the answer that the calculator would actually give you. Okay, and then remember we have to add the +2n pi as well. Now, when we're solving for sine, remember to find the second angle, we would do pi minus the first angle. Well, if we do pi minus -pi over 2, we're actually going to get 3 pi over 2. And -pi over 2 and 3 pi over 2 are coterminal angles. So you would basically be, in a way, identifying the same point on the unit circle. So since we're adding the +2n pi, you don't have to write it separately. Okay. All right. Okay, now, sometimes you may have to use a trig identity in order to solve the equation. Here's an example. We have 1 plus sine theta equals 2 times cosine squared theta. So, you know, my first thought in looking at this, because we have a cosine squared and then we have a sine theta, like, my head is leaning towards factoring, but we don't want 2 different trig functions. So that's why we would use a trig identity, so that we could write this equation in terms of 1 trig function. So what we can do here is we can use our Pythagorean identity that says cosine squared plus sine squared equals 1. And then let's say I solve this for cosine squared, meaning I'll subtract the sine squared. I get cosine squared equals 1 minus sine squared. And so now I can substitute the 1 minus sine squared in place of cosine squared. So that'll give me 1 plus sine theta equals 2 times 1 minus sine squared theta. Okay, so notice now how we have a sine squared theta and we have a sine theta. So now I know I want to try to factor this equation, but before I factor, I have to set it equal to 0. So in order to do that, I would first distribute the 2 to get rid of the parentheses. And then I'm just going to move all the terms to one side. So I'm going to add the 2 sine squared theta and move it over here to the left side. I'm going to keep the plus sine theta, which is already on the left side. Okay, and then if I subtract 2 on both sides, the 1 minus 2 will give me -1 equals 0. Okay, so now I can go ahead and start factoring. The next thing I would notice, though, is that I have that 2 in front of the sine squared. And so in order to factor this, I would first start by multiplying the 2 times the negative 1. This is what I like to call the slide and divide method. Okay, then we can go ahead and break this up. Remember, it factors similar to a quadratic, but like instead of x, we're going to put sine theta. Okay, we're going to think factors of negative 2 that add to 1. So that would be positive 2, negative 1. And then we have to divide by the 2 that we multiply by to begin with. 2 over 2 equals 1. So we'll get sine theta plus 1 equals 0. That's one of our factors. So I'm going to go ahead and also set each factor to the 0, if that's okay. And then our other factor will be sine theta minus 1/2 equals 0. Because again, the idea is after you factor, you set each factor equal to 0. And then we just have to solve each of these trig equations, which are now just basic trig equations. Okay, so here I would start by subtracting 1 on both sides. All right, then we got to use our inverse trig function to isolate theta. And then we'll think to our unit circle for which angle is sine equal to negative 1. Well, again, that would be at negative pi over 2. And then we'll add the 2 and pi. Okay, now to solve our second equation, we're just going to add the 1/2 to each side, getting sine of theta equals 1/2. Then we'll use our inverse trig function to isolate theta. And then we'll think to our unit circle for which angle is sine equal to 1/2. Well, that would be at pi over 6. And also at 5 pi over 6, which again, that comes from pi minus pi over 6, which becomes 5 pi over 6. All right, so these are all the solutions to this equation. Okay, now this last example, you could still fit it under the scenario where you have to use an identity, but what's a little bit different in this example is that we have sine theta and we have cosine theta. Remember in our previous example, we had cosine squared, and so then we were able to use our Pythagorean identity. Well, since neither sine nor cosine are squared, like that's posing a problem for us. So to fix that problem, what we can do is just square both sides of the equation. All right, now, so sine theta minus 1 squared. Remember, that means sine theta minus 1 times itself. You cannot just square each term, you have to FOIL it out. And then we'll just equal that to cosine squared theta. All right, so if we FOIL this out, first outer inner last, we'll get sine squared theta minus 2 times sine theta plus 1 equals cosine squared theta. Okay, now we're going to do what we did in our last example. We're going to replace cosine squared theta with 1 minus sine squared theta. And then that way our equation is in terms of only one trig function instead of 2. All right, now, when I look at this and I see like the sine squareds and then the sine theta, it makes me think I'm probably going to have to factor this eventually. So I know my next step would be setting it equal to 0 so that I could factor. Now, because we have a positive 1 on both sides, those are going to cancel. And so then I would just add the sine squared theta over. And so if you end up adding, sine squared theta plus sine squared theta, that'll give you 2 times sine squared theta minus 2 times sine theta equals 0. So this is one that we can factor by just taking out the greatest common factor. So if I'm looking at both terms, what's common to both terms is the 2 and also a sine theta. So we can actually factor out 2 times sine theta. Okay, now that will leave us with sine theta minus 1 equals 0. Okay, then we'll just set each equation, or excuse me, each factor equal to 0. And then we'll just solve each equation separately. All right, to solve this first equation, we'll divide by 2. 0 divided by 2 is still 0. We'll use our inverse trig function to isolate theta. And then we'll think toward a unit circle for which angle is sine equal to 0. Well, that would actually be at 0 and also pi. Okay, so we'll have 0 plus 2n pi, but also pi plus 2n pi. All right, to solve the second equation, we will add 1 to both sides. We'll get sine theta equals 1. Okay, inverse trig function. And then we just have to think for which angle is sine equal to 1. Well, that is at pi over 2 plus 2n pi. Okay, so these are all the solutions to this equation. All right, so you guys, we'll definitely practice this some more in class tomorrow, or the next day that we have class. But maybe go back and kind of just review. I know that was a lot, so it never hurts to go back and reread through it again. But you'll probably feel a lot more confident with this after you actually do it yourself. So, as always, I appreciate you watching, and I will see you later.